Hello everybody, this is Mr. Bowman. So today we're going to be looking at this rectangles, rhombuses, and squares assignment. So what we're really trying to do is we're trying to figure out if this parallelogram, and it does say it is a parallelogram, which is helpful, is going to be specifically a rectangle, a rhombus, a square, or none of the above. So we're going to do that by looking at the main characteristics of a rectangle and a rhombus. So for a rectangle, they do need to have right angles, so they have to be all the sides have to be perpendicular. And for a rhombus, all of the sides have to be the same length. And then a square would be a combination of those two. It would both be a rectangle with perpendicular sides and a rhombus with congruent sides. So if it's both of those, then it would be a square. If it doesn't fall under either of those, then it would be none of the above. Okay. So I'm not going to run you through all the math on how to do the individual calculations because you've had quite a bit of practice with that. But I'm going to help you figure out what you're supposed to do and how you're supposed to do it. So looking at this, we have a lot of practice finding slope. And this part is going to help us figure out if they're perpendicular or not. So whether it's a rectangle or not. So the slope of GH here, right? You can either do that by using your slope formula, where you take G and H and do y2 minus y1 over x2 minus x1, or you can use your Pythagorean theorem and just use the grid here to count and find the length of those sides. So how much are you going over and up to get from G to H? Both of those are essentially the same thing. They're just different representations. So either one of those will work. So when you're done with that, you'll find out that you do end up going up 3 over 8 for a slope of 3 over 8. And then for a side adjacent to GH, it doesn't actually matter since this is a parallelogram. These are parallel, so they'll have the same slope, and they're congruent, so they will have the same length for when we get to part B. So I'm just going to go ahead and do this one. So I'm going to do KG over here. So to get from G to K, I'm going up 8 and then right 3. So this one's going to be 8 over 3. All right, we're going to leave that for a second and come to the length here, and then we're going to put those together to figure out what's going on. So right now I'm just doing my quick calculations, then we'll do our interpretation. So the length of GH, it's probably easiest in my opinion, since we already half did it, is use the Pythagorean theorem to find that other side there. So you could use the distance formula if you want, but we already found the sides when we counted here, so I think it'd be easiest just to use our A and B and figure it out that way. Notice it does want exact answers, not decimal approximations, so that means we're going to use our square root and simplify it if we have to, but we're going to leave our answer with the square root unless it comes out perfectly as a integer. So, all right, so GH here, so I have 3 and 8, so that's 3 squared plus 8 squared, and then it will be the square root of that. So I have 3 squared is 9, 8 is 64, 9 plus 64 gives me 73. So my length is radical, or the square root of 73. For this one, I have 8 and 3, so 64 plus 9, which gives you another 73, right? It doesn't matter which order you add those in. So now I don't need my picture because I have all my information I need here. So is it a rectangle? So are these opposite reciprocal slopes? No, they are reciprocals, but they're not opposite signs. They're both positive, so that's not going to work. Okay. So it's not a rectangle. Is it a rhombus? Are the lengths the same? And yes, they are. And it can't be a square unless it's both a rectangle and a rhombus. So it is not a square because it's not a rectangle, and it's not none of these because it is a rhombus. So that's where we're going.